Hello, welcome back. This will be the last video for our practice problems for exam 2. So numbers 8 and 9 here, we're going to be doing confidence intervals. So what we did in chapter 10. So you construct confidence intervals here. So once again, we're going to write off to the side what we know. So we have a simple random sample of 758 individuals. So our n here is equal to 758. We have an average sample income here. So this is where our average sample, right? So our x bar is going to equal $72,487. We want to be virtually certain, so we're going to use a 99% confidence interval. Part A, we're going to be using a standard deviation of 1,254. We're going to calculate this using a 99% confidence interval. So when we're looking at confidence intervals, we have certain, our formula is our x bar plus or minus our z of 1 minus alpha over 2 times the standard error of x, right? That is our equation here. And when we're looking at our z of 1 minus alpha over 2, so we're taking in the confidence interval, that's our percent. And on page 223 in the book, it gives you a chart that tells you at alpha level and at the confidence level what your z values are. So if you look at 90%, your z of 1 minus alpha over 2 is going to equal 1.645. And at 95%, it's going to equal 1.96, and at 99%, it's going to equal 2.576. Notice that these do go 3 decimals out. These are pretty standard to know. When you see this on the exam, calculate at 90 or 99%, make sure you're using the full values that are given to you on page 223 in the book. You can calculate these values still, by using the back, but you're going to want to use these because you'll have a more accurate answer. So when we're doing our confidence interval at 99% with all the information that we've been given here, we're going to set our problem up. So our x bar, 72487, plus or minus, since this is 99% confidence interval, we're going to use the 2.576 value times our standard error of x, which is 1,254 over the square root of your n, which is 758. So again, I'm going to, I normally reduce this all down, but I'm going to reduce it down really quick for you. So when you take 2.576 multiplied by the standard error of x, you're going to get a value of 17.3308. When you take 27487 plus or minus this value, your confidence interval is then going to be 72,369.669. I know we're using dollars, so you really only need to go to 2 decimals, or you can round that up, but just for us to be even more accurate, we're going to leave it there. And then our upper bound confidence interval, 72,604.33. We'll just leave that one there like that. So that is your confidence interval. Anytime you see the word interpret, when you interpret, we're going to be writing out. So this is where we're going to say that we are what percent confident? 99% confident, because that's the one we did, right? We did a 99% confidence interval. We are 99% confident that the true mean annual income is between the interval of 72,369 9.669 to 72,604.33. So that is how you interpret it, and you go from there. And then the last part here that we'll be going over is in chapter 9. Oh, what I want to say here is when we interpret the confidence interval, when you're interpreting it, you want to say that you're 99% confident or 95 or 99. So I'm not too picky on the wording, but I want to see that you're what percent confident that this interval is going to capture what true mean value. So here we're looking at annual income, or are you looking at BMI? Are you looking at age? What value are you looking at? What is the true mean value? What is it going to be within this interval? So those are the keywords. We want to see what percent confident you are that you're going to find what you're looking for between this interval. That is how we're interpreting it. Next part here, I'm just going to kind of go really quickly over it. So now we're just constructing a 90, 95, and 99% confidence interval for all the values shown above, where we have an n is equal to 416. We have a x bar average is equal to 16.2. We have our standard deviation was equal to 2.4. And then once again, you can go to page 223, sorry, blinking, 223 in the book, and you can find your z values here. So I'm just going to say that this is going to be your 90% confidence interval, this is going to be your 95% confidence interval, and this is going to be your 99% confidence interval. So I'm going to set this up very quickly. So at 90%, you're going to have 16.2 plus or minus your 1.645 times your standard error of x, which is 2.4 over the square root of 416. Reduce this down. 16.2 plus or minus 0.1934, which is going to give you the interval of 16.0066 to 16.3934. So remember, you always want to put these in ascending order from least to greatest. For 95, once again, 16.2 plus or minus, now you're doing 1.96 times the standard error of x, 2.4 over the square root of 416. Reduce this down, 16.2 plus or minus 0.2304. And your confidence interval here is going to be 15.9696 to 16.4304. And as you can see, as you're doing these confidence intervals, right, as you get more, low battery, as you're getting more accurate with your confidence intervals, your confidence interval is going to get bigger. And that makes sense because you want a wider net with a more accurate confidence interval. That means you're going to be more accurate in your estimation here. 0.1176. So if you want the 2.4 divided by the square root of 416 is 0.1176. Reduce this down, 16.2 plus or minus 0.3029. And as you can see, 99% confidence interval should be the widest confidence interval we have. So 15.8971 to 16.5029, because you want to be the most accurate, you're going to want to include the most participants. You know, if I had a group of college students and I want to say I'm going to be 99% accurate, I can guess the age, or the average age in this classroom is going to be between 0 and 100. I'll probably be 99% accurate, if not even more accurate, right? Since I know it's college age students, if I want to say the average age in this classroom to be 99% accurate will be between the ages of 18 and 50. The wider the range is, the more likely I'm going to capture everybody in there, and the more accurate I'll be. So that is our confidence intervals. On this one we didn't have to interpret, but I thought this is a very good practice problem sheet. It kind of goes over everything you kind of need to know for the exam coming up. If you have any questions, always feel free to reach out to me. If you want to come in and visit me during my office hours, please come and do so. I'm normally in here just waiting for students to come and ask me statistics questions, and I'll be more than happy to talk your ear off and give you all the information you want to know. Of course, there's a couple things on this packet that are going to be on the exam that were not in here, but the majority of it is covered here. An example of that would be you need to know how to calculate sample size, how to find a value of n. And remember, when we're finding a value n, we're never going to round down. We always want to round up on sample size. We want to include more people in our study in there. The other big thing that's not in here is finding z percentiles. If you're given a z percentile, then using that to find the z-score associated with it. And we want to use Price is Right rules there, where we want to find the closest to that value without going over that value. Between those two things and this packet, I believe that will cover the majority of the stuff on the exam. And once again, if you have questions about anything, please let me know. I will see you all or talk to you all soon.